Hi, today in IM1 we're going to talk about 7.2, which covers Box and Whiskers. But before we get started, I want to talk to you a little bit about two of the other main forms that they're going to go over with you in the high school eventually. And so I thought you should be familiar with them too. So this picture here, this table, is a representation of the bunch of grades from an Algebra 1 test that a teacher gave, and the teacher's name is Mr. Fallweiler. But Mr. Fallweiler put all these things on the table, and it's kind of busy to look at things on a table and kind of hard to represent whether there's a problem or not. But he sees a lot of 60s in there and maybe a couple of 50s, and so he's a little worried that the students didn't do very well. So the first thing that he does is he constructs a dot plot. To make a dot plot, you just make a line, you find your minimum and your maximum, and then you put 1x for each data that fits that. So we can see here there was 3 students that got a 55, there was 1 student that got a 98, and so forth. So that's how you make a dot plot. Then he decided, I'm not sure that works, so I'm going to make a histogram. Now, if you remember from last time, the histogram shows the range of things. So this shows the individual grades, and the histogram shows the grades grouped by the variance. So we've got the kids that got 50 to 60 are here, and that means there's 7 students, because we can see that. And 60 to 70, there were 8. 70 to 80, there were 5. 80 to 90, there were 4. And 90 to 100, there were 2. So we can see that, yeah, there is a problem here. And if you look, remember that we talked a little bit about the shape of the graph. Both of these indicate that the scores are skewed right, meaning they're skewed toward lower grades. So that's important to understand. Well, then he's worried and he gives the test back, and the kids argue that more than half of us failed the quiz, so you should let us retake them, because that's his policy. And then he reminds them that a grade of 56 is failing. So I want you to look at these graphs, and I want you to think about them and think about how either the students or Mr. Fallweiler could argue about which should they retake the test or not. Okay, so let's go and learn about Box and Whiskers. Okay, so a Box and Whisker plot shows the variability of a data set along a number line using the least value, greatest value, and the quartile. So there's certain things that we find when we have a set of numbers, and you can see we have a number line. They didn't put values here because it will depend on the values of your data, but the first thing you want to come up with is you want to take your data and come up with the 5-number summary. So the 5-number summary, and I always want you to write it in order, starts with the minimum, that's the lowest number. Then you have quartile 1, then you have the median, and we already learned how to make those, find those, then quartile 3, and then the maximum. And we're going to go over how to find that. But the interesting thing to look at is the first quartile is quartile 1. The quartile 2 is called the median. Quartile 3 is called quartile 3. And then that's what it is. So each one of these represents a quarter of the data. Okay? And notice they're not always equal. Okay, so let's make a Box and Whisker plot. They gave us some information here, a number of ages of members of a backpacking expedition in the mountains. And they want us to make a Box and Whisker plot of it and then interpret it. So let's go. So the first thing that we're going to do is we're going to order the data. You put the data in order from least to greatest. That gives you your least value and your greatest value. These are numbers that are in the data set and represent those two numbers. So remember, that's our 5-number summary that we start with. So we have the least and the greatest now. The next step is to find the median. So we're going to count how many things we have, how many pieces of data we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we want to go right to the middle. So we're going to go to 25 and we're going to see what happens. So here it is outlined for you a little bit clearer. So you can see that we have the minimum and the maximum all marked, and you can see that they cut the whole thing in half and they found their median. Now, important to remember, If there's an even number of data points, the median will be in between two numbers, okay? If the two numbers are the same, then the median will be the same as those 2 points. If they are different, however, then you have to find the average of them. So the halfway point is your median. Then you're going to take each half, what's left, and you don't count the median. So if the median is the middle number, then you're not going to count it, and you're going to count the ones to the left and right. So we know now, because we divide it in half, there are 6 on each side. So we go to the middle number. So it's kind of like finding the median of the lower half. Remember that if you have two numbers that are not the same, you have to add them together and find the average. So your first quartile is 23. Then you're going to do the same thing on the upper half, halfway. So you take 28 and 30, add it together, divide by 2, and quartile 3 is 29. So now you're going to draw a number line that includes the least and greatest values. So there's 18, there's 30. You're going to put those numbers that you got up here on that number line. So you put the 18, the 30, quartile 3 is right there, the median is there, first quartile is 23. And then you take the middle numbers, the middle 3, and you draw your box. And then you extend the whiskers out from the box. So this is what it looks like when it's all done. And I can see here that my whisker is much lower over here on this side. But it's important that you remember that this represents 25% of your data numbers. Remember, it's only 3. Okay? This represents 25%. Again, it's 3 actual ages. This one's 25%, and this one's 25%. So it's important that you understand that each of those is 25% of your total. Now, what does this show me? It looks like, remember we talked about what the data set looks like? This looks skewed left. Remember, it's whatever edge is the longest, or you could say whatever, it's skewed away from the left, but it's skewed left is how you would say it. So the bulk of the data is on the right. So if I did a box and whisker plot, not a box and whisker, if I did a dot plot, that would look like this, and we can see, yep, most of the data is on this end. Yeah, we have one extra one here, but it's most of the data is to the higher numbers. Okay? So I would say most of the people are over 25, and I would be correct. All right. So when you're interpreting a box and whisker, and I went over this a little bit on the slides before, each one of these pieces are worth 1/4 of the data. So if you had 100 numbers, there would be 25 numbers in here. So this is 25%. Again, 25%. Now, a lot of times they'll refer to the middle box altogether because they'll say the middle half of the data is in the middle box. So this represents half of your data, which is kind of important when you're looking to examine the bulk of the data. Okay, so that's the kind of things that you're going to refer to. So the interquartile range is the measure of spread used with the median. So remember we talked about the standard deviation is the measure of spread that we use with the mean, which is a measure of center. Well, when we're doing box and whisker plots, our measure of center is the median, and the IQR is the measure of spread that you use with that. So what is that? Well, you have to take your third quartile and your first quartile and subtract, okay? And it represents the middle half of the data, okay? So now we have two measures of center. We have the mean and the median, and we have two measures of spread, the IQR and the standard deviation. You only use them with the one that they're assigned to, okay? So that's real important. All right, so let's go back to the algebra test. Remember, the students were arguing that more than half the kids failed the test, so they think Mr. Fulweiler should let them retake it, and he reminded them that a grade of 56, which happens to be quartile 1, is the failing grade. So does it look like the kids are right? I can see that 25% of the students flunked it, But remember, each section is 25%. 75% of the students did better than that. So the kids were wrong, and it's up to Mr. Fulweiler if everybody gets to retake the test. Okay, so I put these on here just so you could compare and remember how things looked. Remember that it's hard to see because they have so much of this graph empty, but if you just looked at it here, you can see that this one is skewed to the right skewed right as well. So we can go skewed right, skewed right, skewed right. So it doesn't matter how you show your data, you're going to be able to tell whether it's skewed or not. And the fact that it's skewed means you're going to use the median and the IQR. That's the main reason that you want to know the shape of your graph. Okay? So when the data is skewed, the median gives you a better representation of the data because the median stays with the bulk of the data. Okay? The median here is right about there, which is where the bulk of the data is. Okay? So just an interesting way to look at all of them and compare them. Okay, on page 198 of your journal, we're going to do this first one together, and then you guys will get a chance to do one on your own. So the first thing I want to do is put my numbers in order. Boom. And then I'm going to find my minimum and my maximum. So I'm going to go over to my graph, and I'm going to go 4, 5, 6, 7, 8, 9. I don't need any more numbers than that. Then I'm going to find my median. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 pieces of data. So if I count over 4 each way, the middle number is 7. So that is my median. And remember, when we're calculating the quartiles, we do not use the median. So I'm just going to use these 4 numbers, and I go right in between the 2 middle numbers, and my quartile 1 is 5.5. And then my quartile, so I go over here, the middle number of these is 8, because 8 plus 8 is 16 divided by 2. And now I'm going to mark all those my 5-number summary on my graph. So I'm going to say my 4, then my quartile 1 is 5.5, and I learned lines. You can use dots if you want. The median is 7. The quartile 3 is 8, and the maximum is 9. I take the middle 3 and I make a box, and then I make a line from the box out to my whiskers. And there is my box and whisker plot. So it should look something like that. And remember, your numbers should be even, okay? Uniform. So go ahead and try this one. Remember the steps, put them in order. Find your 5-number summary, and then put your 5-number summary as the endpoints on your graph, and then make your box and whisker. Okay? So go ahead and push pause and give yourself a minute to do that. Okay, so here is what you should have come up with, and you can see here's your 5-number summary. So make sure that your numbers match the 5-number summary. If it doesn't, you need to ask questions. Remember, first thing you're going to do is put them in order. Okay? Alrighty. Okay, so now we're going to interpret a specific box and whisker plot. And this one's kind of cool because it has a lot of different things on it that you might not understand normally looking at it. So this box and whisker represents the length in seconds of songs played by a rock band at a concert. Okay, so find and interpret the range. So range is the maximum minus the minimum. So the least value is 160, the greatest is 300, so the range is 140 seconds. That means that the song lengths vary by no more than 140 seconds. It also means that the shortest song is 160 and the longest song is 300 seconds. Okay? 5 minutes long. All right. Now they want you to describe the distribution. So remember, we've got to think about those 25%, and that's what you're going to talk about. So the 25% of the song lengths are between 160 and 220. 50% are between 220 and 280. And then 25% again is between 280 and 300 seconds. The interquartile range would be 280 minus 220, which is 60. And that's going to say that the middle half of the songs vary by no more than 60 seconds. So they're all within a minute of each other, okay? And are the data more spread out below quartile 1 or above quartile 3? So this is when we look at our whiskers and we go, whoa, that is a much longer whisker than that one. And so here's how you would interpret it. The left whisker is longer than the right whisker, so the data below quartile 1 are more spread out than the data above quartile 3. Remember, there's still the same number of data points here as there are here. So this just means that those, whatever the 4, the 10, are spread out more than this 4 or 10, because it's the same number of data pieces or points in each section. Okay, so that's really important to understand. Okay, so I want you to try and do one of these interpretations. So I want you to choose to do one of these problems, and I'm going to tell you to push pause for a second and see how you do with interpreting. So remember, you're looking at the 25%, the 50%, and the 25%. You're comparing the different sections and talking about what you would find. So go ahead and take a minute, push pause, and see what you come up with. And then you can look at the answers and identify if you understand or not. Okay, so here's the basics, and here's the interpretation. So that's what you should figure out of each of them. So you should know what your 5-number summary is for each of them. Make sure that you got the 5-number summary correct, and then you want to interpret. Okay? All right. So these are different shapes. We've talked about being skewed left or right before. So if the whisker on the left is longer, then it's skewed left. If it's pretty even, they don't have to be exact, but if they're pretty even, see it says about, then it's symmetrical, and you want to look at the box too. Because if you have like this, that's not symmetrical, okay? There's a whole bunch here. That means 50% of the data is over here, and 50% of your data is here. So you got to be careful with that kind of thing. And then this one is skewed right. You can see that the right whisker is much longer, and so it would be skewed right. Okay? So always look at how you curve the shape of the data. That will help you make that determination. Okay, so now we're going to compare box and whisker plots. And this is really common for them to give you 2 different box and whisker plots to compare. So the first thing they want you to do is identify the shape. So I'm looking at this one, and it has a much longer whisker here. So I'd say my class is skewed left. Okay, then I look at my friend's graph, and it looks pretty even. So I'd say that this one is symmetrical. Okay, so interesting thing to look at. And for your class, the left whisker is longer than the right class, so this goes along with what they said. And so ours is skewed left, and theirs is symmetrical. Then it says, which test scores are more spread out? So look at the range. Your friends goes from 60 to 100, so they have a range of 40, and the middle 50% ranges from 70 to 90. So it has a range of 20. If I look at mine, my range is from about 67 to 100. So that's a range of 33. And if I look at my middle 50%, it only goes from 85 to 95. So that's a spread of 10. So it depends on what you're looking for here. If you're looking for how how did they score in the higher points, then your class did much better. Okay? So the test scores in your friend's class are more spread out. Make sure you know what they're asking about. Are they asking about all of the test scores? Then you look at the entire range. They're talking about the middle 50%. Then you look at the IQR, which is quartile 3 minus quartile 1. Or if they're just asking about the higher scores or whatever, you need to make sure you read the questions so you know what you're interpreting. Okay, so I want you guys to take a minute to compare these two. They're pretty basic so that you can see exactly what you're doing when you're interpreting and comparing two different Box and Whiskers. So look at each question and then push pause and see if you can answer them without my help. When you're done, hit start again. Okay, so the first thing they ask you to do is identify the shape. Their meaning is it symmetrical or skewed. So look at your data, and it looks to me like state A is symmetrical. Then we look at this data. Whoa, state B definitely looks skewed right because 50% of the data is way over here, so I would say it's skewed right. Which state tornadoes are more spread out? State A goes from 0 to around 15, and state B goes from 4 to 27. So that means state B is more spread out. And you can also look at the interquartile range. Notice it mentions that too. And it says those are from 4 to 10. And this one is 7 to 19. So again, a much bigger spread in state B. Okay, and then make sure you read the questions carefully. Which state had the single least number of tornadoes in a month during the year? So you want to look at the minimum. And the minimum in state A is 0 because there was a month, at least one month, that had 0. Okay? Now, an important thing that you need to know about Box and Whiskers is if they ask you how many months had 6 tornadoes, you can't tell that. You don't even know if one month had 6 because it's in there. Okay? The only number that you know is sure to exist is the minimum and the maximum. Those are definite numbers of your data. But everything else might be in the middle of your data, in between two numbers, so you can't say. So you can't give exact data from a Box and Whisker plot. If they give you the list of data, that's where you have to go back to. Okay? All right, we're going to go back. Okay, before we finish up, I just want to remind you that if you looked at the spelling bee scores from the last slide, remember that we had the standard deviation that we calculated for each of these students, and his was the highest because he had the biggest spread. So remember, standard deviation is a measure of the spread of the data. And if you look up here, these go right along with what we have here. Timar has the biggest IQR. Okay, his score is spread. This is quartile 3 minus quartile 1. And you can see that it goes along with Leah has the smallest, Aaliyah, and then Jax is the middle. So you can see that their Box and Whiskers would give you the same kind of measurement. Now, since theirs were symmetrical, all of their data was symmetrical, we would use the mean and standard deviation. These two go together, okay? When we use the mean, we use standard deviation. When we want to use standard deviation, we have to have the mean. If you can't find the mean, you can't use standard deviation. When we're using the median, which we use in Box and Whisker plots, then we use the IQR. So this is our measure of center, okay? Tells us where the center of the data is. And this is our measure of center here. And then the standard deviation and the IQR are the measures of the spread of the data. So it's important to remember those. These go together and these go together. Okay, so I wanted to show you that so you could compare them to what you learned about standard deviation. Okay, so the 5-number summary is always given in this order. Minimum, quartile 1, median, quartile 3, maximum. We use median and IQR especially, I mean, we could do it with a symmetrical graph, or when we can't find the mean, but we especially use it when the data is skewed. So remember, that's when you're going to be using these, and you'll be in good shape. Take care.